Algebra 2, target 31, I can solve a rational equation. This target will finish up our Unit 5 on rational functions. There will be two parts to this target because there are basically two general forms of equations that we typically see with rational equations. The first of those is what we call proportional equations. So that's what we're going to focus on in this first part of target 31, using cross products to help us solve these rational equations. All right, so a proportional rational equation is one of the form a over b equals c over d. Right, so you have some expression a over some expression b equal to some expression c over some other expression d. Now, b and d can't equal 0, obviously, because we can't have 0 denominators. Right, but there are no other restrictions here. So this type of equation, when it's in this form where you have one fraction equal to another fraction, can be solved in the same way we solve proportions. So when we solve proportions, we use the cross product property, which says that if you have a over b equals c over d, that is equivalent to taking the cross products. So the numerator of the first fraction times the denominator of the second, so a times d, equal to the numerator of the second fraction equal to the denominator of the first, so b times c. Right, and in doing that, okay, we no longer have fractions, right, in our equation. And what this does is it creates a linear or a quadratic equation from the rational equation. And since we know how to solve linear and quadratic equations, then we'd be able to solve from there. All right, so let's jump into some examples, okay, looking at how this works. The first one, we have 3 over x plus 1 equals 9 over 4x plus 5. So since it is in that a over b equals c over d form, we can use the cross product property. So we take 3 times 4x plus 5. Now it is important that we're taking 3 times that entire polynomial in from the denominator and not just times the 4x. So we are going to need to distribute this. So we have 12x plus 15. All right, then we take the numerator from the second times the denominator from the first, and again, that's times the entire denominator of the first fraction. So we distribute again. So this is 9x plus 9. And then, like I said, what happens here is we end up with a linear equation, and we can solve that by getting all the x's on one side. So we subtract 9x from both sides. We get 3x plus 15 equals 9. And then solve for x by undoing the plus 15 by subtracting 15. Get 3x equals negative 6. And then divide by 3 to undo the multiplying by 3. So we get x equals negative 2. All right, now, because of the way we're solving these with the cross products, it is possible for us to introduce extraneous solutions, okay, solutions that appear to work. Okay, we do all the work correctly, but when we plug them back in, they don't work. So it is important to check your answers. All right, so let's plug the negative 2 back into the original equation. So we have 3 over negative 2 plus 1 is negative 1, equal to 9 over negative 8 plus 5 is negative 3. So simplifying, you get negative 3 equal to negative 3, which checks out. So x equals negative 2 would be the solution. All right, why don't you go ahead and give this example a try. 3 over 5x equals 2 over x minus 7. Once you've finished, restart the video. I'll show you the answer. All right, so again, this is a proportional rational equation. So we take 3 times x minus 7. Okay, set that equal to 2 times 5x, so it would be 10x. So we have 3x minus 21 equals 10x, and we want to solve that. So subtract 3x on both sides. Gives me negative 21 equals 7x, and then divide both sides by 7 to get negative 3 equals x. And checking your answer, you get 3 over negative 15 equal to 2 over negative 10, which is negative 1/5 equal to negative 1/5. So it checks out. All right, next example. Okay, again, give this one a try. And when you've got your answer, restart the video. All right, again, proportional rational equation using cross products. We're going to take negative 4 times x minus 3. Set that equal to 5 times x plus 3. Distribute, we get negative 4x plus 12 equals 5x plus 15. And now we want to solve that. So let's get rid of this negative 4x by adding 4x to both sides. Leaves me with 12 equals 9x plus 15. Subtract 15 on each side to get rid of the plus 15. Leaves me with negative 3 equals 9x. And then divide by 9. So we get negative 1/3 equals x. All right, going back and checking it, got negative 4 over negative 1/3 plus 3 is 2 2/3, so that's 8/3. Equal to 5 over negative 1/3 minus 3, so that's negative 10/3. So negative 4 divided by 8/3 is times 3/8. This is 5 times negative 3/10. So we simplify, this is negative 12 over 8, okay, negative 15 over 10, so that's negative 1.5 equal to negative 1.5. So it does check out. So that's your answer. All right, one final example. Go ahead and give it a try. When you're ready, restart. All right, so again, we have proportionality here, so we're going to use cross products. So 1 times 11x plus 8 is just 11x plus 8. And then x times 2x plus 5. Right, distribute the x. We're going to get 2x squared plus 5x here, all right, which makes this a quadratic equation, which means we're going to need to get it set equal to 0 to solve it. So subtract 11x from both sides, subtract 8 from both sides, gives me 0 equals 2x squared minus 6x minus 8. Now everything here is divisible by 2, so I can divide the entire equation by 2 and get 0 equals x squared minus 3x minus 4. And then solving that, I can factor that because this will equal x minus 4 times x plus 1. And if I set each one of those equal to 0, I would get x equals 4 or x equals negative 1. All right, and then we need to go back and check our answers. So if we check x equals 4, we'd have 1 over 8 plus 5 is 13 equal to 4 over 44 plus 8 is 52. So 4 over 15 simplifies to 1 over 13. So that checks out. If I check x equals negative 1, we've got 1 over 3 equal to negative 1 over negative 3. So that's 1/3 equal to 1/3. Right, so that checks out as well. So we do actually have 2 solutions that work. Right, so one thing that we need to understand when we solve these is we're not always going to get just one solution. Sometimes we might get 2. Sometimes we might get none. Right? We may end up with an answer that doesn't work, right? And that's an extraneous solution, which means there would be no solution. Right? If you only have one, okay, and it's extraneous, then there would be no solutions. So it's certainly possible to have no solutions, or one solution, or two solutions. And that'll be it for this first part of Target 31.